Hello students, subscribe to my channel Mathematics Helper and hit the like button of videos to get more new updates in the easy way. Hello students, so today we are going to start exercise 1.2. So I want to review the previous work which you did earlier in 1.1 already. So you know about real numbers, definitions of rationals and irrationals. Hope they are clear. So real numbers are collection of rationals and irrationals. And I hope you know what are rationals. Rationals are actually having all these three categories: natural numbers, then whole numbers, and lastly integers. So all these types of numbers we can write as rationals because we can mark 1 in the denominator of every number out of these, and if we mark 1 in the denominator of all these numbers, then they will behave like rationals, that is in the form p upon q. So they will be in p over q form. So numbers which are not rationals, they are called irrationals. So next you have to remember this difference, because even after telling so many times in the class, students feel difficulty to remember their differences. So it should be very clear to you first, because this is the basic difference in these two which you have to remember. Then only you will be able to write about rationals and irrationals very clearly and frequently. There will not be any confusion in this case. So let us start with the definitions. Basic differences in their definition, very clearly it is given: any number of the form p upon q not equal to 0 means denominator should not be 0 of that number, where p and q are integers. Then any number which cannot be written in the form p over q, that number is called irrational. So rationals are in p over q form and irrationals are not in this p over q form, and they are of p over q form. Very first difference. Then there are some examples which we have to remember. As discussed earlier, natural numbers, whole numbers, integers, they all are called rationals. So you have to remember their examples. All natural numbers, all whole numbers, all integers, they all are called rationals. Then you can mark some examples by yourself even. All numbers like minus 2 upon 5, 1 upon 5, 3 upon 7, 9 upon 2, etc. Or like this also: 0.001, 001, 001, so on. And this one 0.6 bar. This is called bar. In next video you will get details about it, because actually we have some work related to this in 1.3. So you will get details about these things or these numbers in next video. So here irrationals, you have to remember pi. Hopefully you know what is pi. Pi is actually 22 upon 7, and when you divide 22 by 7 you will get answer like this. Here only 3 decimal places are given, but there are so many. You will see in your book also pi given with 50 decimal places. Another number, square root of 2. Its answer 1.414 and so on. It is impossible to find complete answer of this number. Similarly, under root of 3 or square root of 3, 1.732, so on. There is no end of this number. Square root of 5, 2.236, so on. Square root of 6, 2.449, so on. Then there are some other examples: 0.10, 100, 1,000, so on. 0.70, 7, 00, 7,000, so on. So there are some examples you can create by yourself also. That is not a difficult work for you. Third difference: what is the type of decimal expansion? See, it is actually about these examples. Here we have these different examples in which there is no end. Dots means there is no end. We can continue up to infinitely many steps. So here what you just see, observe, what you have here? 0.001, 001, 001. While speaking even, you see, same digits are coming again and again. So you can mark this number as 0.001 bar also. So remember the type of decimal expansion for rationals. Either terminating. Terminating means complete answer. We can give some examples here like 0.5 only, which you will get after dividing 1 by 2. In this case, your answer is complete 0.5. So this kind of decimal expansions are called terminating. Another category which you saw here, that is non-terminating, recurring, or we can say repeating decimal expansions. Non-terminating means there is no end, and reoccurring means same digits are coming again and again. So we can mark in any form, this one or the other one with bar, to make it more simple. And secondly, you can easily distinguish in these two type of decimal expansion in irrationals. It is non-terminating and non-reoccurring. Non-reoccurring means there is no repetition of numbers. So here also near about same, non-terminating, but you have to remember non-reoccurring. There will not be any repetition of digits, so we can't mark bar as you marked earlier in rationals. So keep in mind this. So we will go now for our exercise number 1.2. First question given is, state whether the following statements are true or false. Justify your answer. Justify means there should be some reason of your answer. Otherwise, you will not get proper marks in examination. So question number 1 is, every irrational number is a real number. So to give answer of this, you should have knowledge of this combination of rationals and irrationals. See, real numbers are collection of rationals and irrationals, and question says you have to check every irrational number is a real number. See, irrationals are part of real numbers. So you can easily give answer of this also. Just try to think. So its answer is, it is true or false? It is true, because by real numbers contain all irrationals, or they are collection of rationals or irrationals. You can give answer in that way also. Now question number 1, second part. See what is given. Every point on the number line is of the form square root of m, where m is a natural number. I hope you know about number line. Usually we mark number line with these values. See, I am writing few values out of all the values of number line. It is impossible to mark complete number line. According to our requirement, we are marking here. They have given every number on the number line is of the form square root of m, means all these came by writing square root of some value, but that value is a natural number. Just try to think, whose square root gives 1? That is 1. Whose square root gives 2? That is 4. Whose square root gives 3? 9, and so on. You can go further. What about this 0? 0 is square root of 0. But if we see, 0 is not a natural number. All these are natural numbers, but 0 is not a natural number. So 0's square root is 0. What about minus 1? Whose square root gives minus 1? Or these numbers? We don't have any value to mark negative answers with the help of square root of natural numbers. So all these numbers will help us to give answer of this part number 2. So we will prefer counter example here. We will take an example to give answer of this. You can mark here minus 2 is a number is a number on number line, but it cannot be written in the form, which form? Square root of m, m where m is a natural number. So remember, which cannot be written in the form square root of m, where m is a natural number. Next one, every real number is an irrational number. They are saying every real number, all real numbers, that means they all are irrationals. But you know, reals are collection of rationals also. So they are only saying all reals are irrationals. So very clearly you can say it is false, because you can give reason here. Reals contain rational numbers also. This is our question number 1. Now question number 2. Are the square root of all positive integers irrational? Just try to think. Square root of all positive integers always give us irrational answers? Then they have given, if not, give an example of square root of a number that is a rational number. So very first thing you have to answer, it is true or false. So we will say it is no. And reason should be there, because you can take some example of one positive integer which gave us rational value. Try to think. You know, some examples are given on number line also here. See. So we will say just okay, 4 is a positive integer. 4 is a positive integer. And what about square root of 4 which gives 2? And you can mark 2 as 2 upon 1. That is which form? P upon Q. Q not equal to 0. So therefore this 2, or which is actually okay, square root of 4. So we can say square root of 4, that is 2 or 2 over 1, is rational. This is our counter example which help us to give answer of part number. Students, our next question is question number 3. Show how under root 5 can be represented on the number line. So you have to locate this on number line, and better if you prefer graph paper for this. That will be very easy for you, because this under root 5 is an easy number to locate on number line with the help of graph paper, because already you will see vertical, horizontal, intersecting lines on graph paper, and you can easily convert them into number lines. But see, I am just marking one simple rough diagram for you. You try to draw it with the compass. That would be very easy for you then. So very first thing, draw a straight line with the help of scale. Then it is your selection what you want to use. You can take 1 centimeter as 1 unit or 2 centimeter distance as 1 unit. Very first thing, locate a point on number line. Then take 2 points at same distance. For example, I am taking 2 centimeter distance as 1 unit. So after 2 centimeters mark 1, and after 2 centimeters more mark 2 on it. Then if you have compass or protractor, then use that, draw a vertical, means perpendicular line with the help of D or protractor. So with the help of that protractor you can mark perpendicular on it. Then you know what is 1 unit distance? Our 1 unit distance is 2 centimeters. So with the help of scale, from this point A, select another point B to which you can mark at distance of 1 unit. And what distance was here? It was 2 units. Then with the help of scale, join A with B. Straight line should be there. See, next you have to do this one work. You have to select this right angled triangle, and in this right angled triangle, see the name, it is OAB. Just use Pythagoras theorem which you used earlier in your lower classes. Simply hypotenuse square, this is hypotenuse, this one is base, and this one is perpendicular. So use Pythagoras theorem and solve it for hypotenuse, and you will get answer of OB as under root 5 units or square root 5 units. Then place pointer of compass here on O, open it up to B, up to this point, and using this OB as under root 5 length, draw an arc, and you will see this arc will intersect your number line at one point. You can give it a name, you can mark it as E also, any name you can give, so that this distance from O to E, it will be your required square root of 5 units. You can add steps of construction also, and there is no problem in forming these steps. Steps of constructions are required actually in your class 9th, because there are some additional marks in checking also. So remember, add steps of construction also. You can use own simple wording to write steps, different steps of this. So students, don't forget to subscribe my channel and hit the like button. Support me to add some other videos which are beneficial for you people in simple way, and to make all the concepts of all the classes clear from 9 to +2. I'm just trying to do the new things, new concepts I will try to explain in next video. So don't forget to subscribe the channel. Thanks for watching.